welcome everybody to this session hosted by the Australian Prevention Partnership Centre. It's the end of project webinar for a really exciting project looking at modelling around childhood overweight and obesity and addressing overweight and obesity using big data and dynamic simulation modelling. I'd like to start by acknowledging the traditional owners of the lands from which we're all joining today. I'm joining you from the beautiful Darawal country of the Wadi Wadi people, and I'd like to pay my respects to the elders past, present and emerging. So why are we doing this project? Why did this project get funded through the Prevention Centre? And it was funded through a programme of work funded by the Medical Research Futures Fund. So there's strong evidence that preventing childhood overweight and obesity is important for the prevention of long-term chronic disease. And we know that studies demonstrate that early interventions can be incredibly effective. But what we're less certain about is what combinations of policies and programs will have the greatest impact and can offer the best value when we're allocating limited prevention resources. And we also know like system science methods like simulation modelling can help us understand complex health problems. And they can forecast the most likely outcomes of alternative policy and program scenarios. So the purpose of this project overall was to answer the question of where can we invest limited resources if we want to prevent childhood overweight and obesity to achieve the best population outcomes and outcomes that are going to be long lasting. So the project brings together a wealth of evidence, clinical and policy expertise, big data, local and international research to provide some evidence-based guidance on the combination of interventions, which ones work best, for whom, and for how long. So with that brief introduction, I'm going to hand over to Louise Freeburn, who's been coordinating this program of work. Louise is an adjunct associate professor with ANU. She's a director of knowledge translation and health outcomes in the data analytics branch at ACT Health. And she's also a member of the Prevention Centre's leadership executive. So thank you, Louise, and I'll hand over to you. And Louise will give a brief outline of the session today and introduce the speakers.
Thanks, Lucy, and it's fantastic to be at this point in the project. It's been a long journey. It's been disrupted by COVID, but we're here and we're presenting some really fantastic results from some great work that's been done. So I just wanted to just give a brief outline of what we're going to cover in the webinar. We have a lot to tell you, so it's going to be a very busy hour. There's going to be 3 presentations, one for each of the main components of the project, and I'll introduce each of those as we get to those. And then there'll be a couple of brief reflections on impact. So there'll be a reflection from myself on the sort of the local and Australian impact of this research. Joanne Okapinti, we're hoping will be able to join us. She's actually currently in the air flying between Brisbane and Sydney, but we're hoping that she'll land in time to join us from the airport to talk about some global developments in system modelling and international interest in this work. And we had hoped that Louise Bauer would be joining us, but unfortunately she has another family thing that has come up for her, and so she's not able to join the webinar today. So unfortunately we won't be getting her reflection on the impact from the perspective of treatment and research into child and adolescent overweight and obesity. So I'll just kick off with an introduction for Professor Nathaniel Osgood. So we're very fortunate to have Nate involved in this project and has been involved for a number of years, starting with diabetes and pregnancy modelling that was done in my PhD that was supported by the Australian Prevention Partnership Centre. And then in this component of work, it was expanding that model to better represent childhood weight dynamics. Nate is the professor at the Centre for Computational Epidemiology and Public Health at the University of Saskatchewan, and he's going to be presenting the findings from this advanced multi-scale model of diabetes in pregnancy. So I'll hand over to you, Nate.
Thank you so much, Louise. It's a real honor to be with you all and share with you some exciting insights from our work here. First, I'd like to offer my most sincere thanks to those who've made this possible, and acknowledge my own presence on living and working on Treaty 6 territory, the homeland of the Métis here. and paying respect to our ancestors at this pace, past and future. So this work, as Louise indicated, involved extensions to a diabetes and pregnancy model of components to capture child weight dynamics and to really allow us to investigate the outcomes in terms of diabetes and pregnancy, but also the feed-through effects on childhood and adult weight outcomes of a variety of non-pharmaceutical public health interventions focused on physical activity, breastfeeding, and dietary intake. Now, this work, as well as some of the work in later talks here, is rooted in the use of dynamic models. And I was asked to provide just a few words about these models. As was noted earlier, these are about complex systems. Traditional scientific approaches have provided profound insight through predominantly reductionist strategies that seek to understand elements of the world by taking them apart into pieces, understood. These give great insight into those pieces and particular mechanisms, but encounter real problems in helping us understand about more complex systems that assemble these pieces into broader structures that involve delays, feedbacks, nonlinearities, that involve network structures, nested levels of context. These complex systems where the whole is greater than the sum of the parts, really require a new generation of methods. And system science methods seek to address these challenges. And one of the most central ways in which it does so is through the use of dynamic models. And these models can be viewed as dynamic hypotheses, kind of concrete operationalizations of our theories about the world, precise enough so that we can test them out by running them in a way that kind of mimics the world and in comparing what we see from the model with what we see from the world. They represent this in a way that captures positive causal mechanisms so that we can investigate counterfactuals, what-if situations that have never been observed in the world. It's not so much that these models embody the truth of the situation, but rather they help us capture our best understanding so that we can more quickly be sped towards that truth by seeing if that understanding aligns with or just doesn't add up in terms of empirical evidence. They help us refine our understanding, challenge our understanding, and root out misunderstandings and oversights so that we can be sped towards that truth, and thereby help us learn more deeply, more reliably, and more quickly about the world. There's many mathematical frameworks for defining models, and this particular one made use of 3 types of dynamic modeling, some of which you hear in later presentations. It was a multi-scale model, and at the base level, the lowest level, it made use of physiological modeling. This involved an earlier model that had been contributed with glycemic regulation and diabetes, involving the interaction of glycemic loads and insulin and beta cell mass and function. But our extensions complemented that with a rich model of body composition and weight dynamics, capturing the dynamics associated with fat and fat-free mass, importantly through childhood and adulthood. And for childhood, this involves some pretty tricky elements because children, we hope, are net energy positive. They have more energy coming in than going out, than they're expending, to allow them to grow. And the model captured this competition between growth processes on the one hand, using that extra energy, and lipogenesis, creation of fat reservoirs. It was a calibrated model involving caloric intake and expenditure, and we captured breastfeeding impacts. So this is a model that takes into account resting metabolic rate, thermic effect of food, physical activity, all these processes which use up energy together with food intake in the context of growth in height and weight. So this is the physiological model, but there was nested in an agent-based model. Each agent had these physiological dynamics in light of different ages and ethnicities and family contexts, captured fertility and births. and allowed us to look at population-wide outcomes. And finally, outside the scope of this presentation, but present in the background, were representation of clinical service pathways, care pathways, on whose load we could examine, and capacity utilization, we could examine the effects of different interventions if we had cared to do so. Now, the model, importantly, in its agent-based component, that middle component, had state charts representing pregnancy, the postpartum period, including a woman's use of breastfeeding for feeding the baby, but risk that they'd fall off, often in a way that can't be easily undone from breastfeeding during that key postpartum period. And we captured its impact on the woman as well as her child, the breastfeeding impact, particularly on energy expenditure. So this model was configured to run in continuous time. The model starts with an 80-year, what's called burn-in period, to make sure it's sort of in balance and better captures the current context. And then it's run for more than 120 years, involving many generations over that time period, capturing the effects of diabetes in pregnancy from one child during one gestation of one child to subsequent children for that same mother, to the next generation, etc. Calibration took place against a set of data I won't have time to talk about. There's a baseline scenario based on the calibrated model you'll be seeing a lot, and then a set of intervention scenarios were run that compare with the baseline. There were diverse outcomes created by this model outside the scope of this presentation, things like particular birth outcomes, NICU needs, type 2 diabetes, health service demand. Our focus here is really on diabetes and BMI as outcomes. And we're interested in those next generation effects, as well as the effects within a given mother. So the intervention scenarios that we sought to examine for comparison against a kind of baseline, a calibrated baseline, involved basically four types of changes from that baseline. Dietary changes, varying with respect to a lot of different attributes. Physical activity, breastfeeding, again, each of these varying, and then combinations of the above. Briefly, these interventions were compared against the baseline over time, and you could see time running along the x-axis here. And you can imagine for a set of interventions, and we had many dozens not shown here, the model running out and looking at, for example, prevalence of diabetes in pregnancy over time for the intervention shown in red versus the baseline shown in black-gray, with confidence intervals around the mean for both. Now, I'm going to be focusing a lot of my attention on a set of interventions which contrast the baseline with primary school physical activity, society-wide physical activity efforts, sugar-sweetened beverage taxes. Roughly speaking, it's sort of roughly comparable. And then combinations of these in some of the interventions. And we're going to be spending particular attention, amounts of our attention, seeing the diabetes and pregnancy outcomes for these. So we're going to look at a fair number of graphs like this, where we have on the y-axis for each of these graphs, diabetes in pregnancy per 1,000 births. And we're going to see interventions laid out here on the x-axis. 0 is going to be the baseline, and the upper and lower confidence intervals are going to be shown with these dotted blue lines. You can kind of see them here as they get wider because of the fewer births occurring in later years. And each of these interventions is being compared against this baseline, and there's confidence intervals for each shown that are hard to see from this level. They're seen a little bit more clearly here. But broadly, what we found through this is that, as one might expect, the diabetes and pregnancy risks go up with successive decades of childbearing. But across many of the decades, these interventions, such as moderate physical activity, sort of on a population-wide basis for the whole or half the population, examined half separately with half, or combinations of that with sugar-sweetened beverage type interventions, those can statistically significantly lower these diabetes in pregnancy levels and do so through the 30s into the 40s. But in later 40s, it tends to run into issues with few births and a set of other factors that make it really hard to bend that curve. For the youngest age groups as well, really changing things materially is hard. If we look at overall diabetes in pregnancy over the life course, what we see is statistically significant results for these type of 4 interventions here, including 5-year primary physical activity interventions in school plus sugar sweetened beverage taxes. When we posit, a little bit of staying power in terms of subsequent adherence. Now, it's important to recognize that some of these impacts are mediated by insulin sensitivity during pregnancy and during the postpartum period. It turns out these interventions, for example, the physical activity intervention on a population-wide basis can raise the level of insulin sensitivity and thereby lower glucose levels during pregnancy that lowers the risk of damage to beta cell mass and function, for example. We also found that sugar-sweetened beverages, beverage taxes, and physical activity combined can really materially shift BMI outcomes, although that wasn't our primary focus here. The combination of the two can be quite powerful in shifting those outcomes. Some of the most interesting results were with respect to breastfeeding. And what we found in a nutshell is that combining breastfeeding on the one hand with physical activity or with dietary interventions pairwise could yield really meaningful decreases in the occurrence of dip births over the lifetime. This may seem counterintuitive because, of course, diabetes in pregnancy one associates with pregnancy period before breastfeeding initiates. But it's important to realize the model captured the effects on later pregnancies, and through a lot of these outcomes that those gains were realized. And it too can shift both in child and mother BMI outcomes as a result. Time is very limited here, and I apologize, but I'll have to end with a brief summary here. To really evaluate public health strategies to reduce dip prevalence, one needs to select judicious interventions. There's a lot of entangled features here: weight and glycemic control, impacts of school interventions and their waning over as one gets into the years of pregnancy, weight dynamics in childhood and beyond in the next generation, and this unique nature of the time of pregnancy and postpartum. To evaluate these strategies, we used a multi-scale model that it would incorporate those physiological components with these population-level dynamics. And we found that initiatives such as sugar-sweetened beverage taxes and realization of broad-based physical activity can notably lower diabetes burden in the 30s in the way that's significant not only statistically, but from a public health and clinical standpoint as well. And elevation in breastfeeding initiation and duration can also be very effective at reducing dip outcomes because of the impact on subsequent pregnancy. Many of these gains are mediated by and themselves contribute to weight reduction in childhood and adulthood because of the reciprocal effects of weight on insulin sensitivity, but also on birth outcomes of setting up a child for greater risk of obesity in the next generation. I regret not having more time to discuss these textured findings, but I hope that gives a little bit of a taste of what we did, and I'm eager to answer questions as the lead student on this effort, Bryce Keeler, will be as well. So thanks so much.
Thank you very much, Nate, and thank you, Bryce, for your contribution to this work as well. We are going to save questions to the end of the webinar. So if everyone can just hold on to questions, I think it would be, we could talk all day about the results from this model. That's a very rich model with a lot of insights that we can learn from. But fortunately, perhaps, we also, we're going to be moving on to Dr. Sandro Sperende, who is a lecturer in epidemiology at Western Sydney University. And Sandro is going to be talking to us today about the findings from a study using app-based data collection methods with young people, and it was focused in Western Sydney. And as you can see from the title, it just happened to be in the field as COVID-19 started to have an impact in Australia. So we had some really interesting findings from this study. So I'll hand over to you, Sandro.
Hello, everyone. Good morning, and thank you for the word. Let's start talking about this. The impact of distance policing during COVID-19. This was a lucky for us that we were able to capture this data. We were conducting a pilot study on Western Sydney adolescent health, and then we were hit by the COVID. So we started to use this data to study the impact of COVID in the lockdown policies on physical activity, well-being, and diet for these adolescents. This is a part of a wider modeling study, and we were trying to to study the feasibility of a cohort of adolescents during this using this Etika app, and we, as I said, we just were lucky when COVID hit us. Unfortunately, we were going to the end of the study period. When the COVID came, we stopped it in 19th of April, and we still had, we already had a few participants there, not as many as before, but we were still able to get a lot of data on that. So we were using for this study, and this is the most interesting part, we were using this Etika platform. This platform allows us to follow the participants with weekly or monthly ecological momentary assessments, so the EMAs. So those are short or long questionnaires that were sent directly to the smartphones of the users, of the participants. And we also collected data from a number of sensors directly from the smartphone. We could collect data from the GPS, the screen state, the app use, pedometers, and others. And this app also allows us to link the smartphone with wearables like the smart watches and glucose monitoring devices, and get data from all of these. And we also have some algorithms to treat this data. And this is very interesting because longitudinal studies are quite difficult to follow and to conduct. And this is a way to connect directly with the smartphones, which are a device that is a device that is always with us nowadays for 24 hours. So this is an example of some screens that the users will receive with short questions like, have you had any alcohol drinks in the last 24 hours? And then yes or not, and then you can go for next questions about how many. You can ask about physical activity. Did you do at least 1 hour of physical activity or moderate physical activity in the last 24 hours? Or did you eat in fast foods in the last 24 hours? And we also can get data, as I said, from the sensors. So every smartphone has sensors. They have accelerometers and other devices inside them. And we can collect data with participant authorization, of course, but we can collect data direct from the smartphones and use this data either to validate the answers they gave to the questionnaires, the self-reported, or to fill the gaps, because we are asking, for instance, did you do any physical activity in the last 24 hours? But we don't know about the rest of the week. So we can use these activity sensors to fill these gaps. And one of the biggest problem is to get people to authorize, and more than that, to get the sensors working. This is an example you can see on the right. The dates are passing on the top of the figure, and you can see some people's GPS. The GPS was one of the most difficult sensors that we get, because people usually set the GPS off and to save battery and things like that. So we were only able to capture data from people with GPS on. And you can see that we are here in January of 2020, and then we have some travels and people walking more around. And as we approach March, the end of March, although we still have some signals, these travelings, they become more and more rare. So, just a little bit. Yeah. Very few travels, people stay at home. So the recruitment is not my main part here. Maybe Luis can talk more about this. But it was through a social network and internet-based campaign to recruit participants. And we got about 1,300 participants initially, and 500 of them had at least one EMA following the baseline. When they accept to participate in the study, they receive a baseline questionnaire and all the authorizations and ethics information. And after that, they would receive weekly a series of questionnaires, and they would agree to give us the sensor data. Those are the questionnaires that we were using. The dietary behavior, we had the baseline weekly EMAs. In physical activity, the baseline and weekly EMAs, those are the main outcomes. And we also had questions about the sleep, screen time. The screen time were collected using both the questionnaire and the sensors. So every time the screen was on, we got a record in the system saying screen on and then screen off. So you can see when you can calculate the time the screen was on and off, and when the screen was on and off. We were not able to get data from what they were doing. This is important. We are not spying on them or seeing the what they were seeing in the screens. Some apps like the Facebook and other social networks, we were able to know they were using or not, but we are not able to see what they were doing. This is very important because, well, this is kind of scary when you see this for the first time. We were collecting data from the smartphone. We were seeing what they were seeing. So nothing different from what Google does with us every time, but we got the authorization for that, and we are not seeing the content. We are just assessing the use. Sorry. And here are some of the posts to recruit people on social network. For this study, we selected a subsample, as I said, with 580 participants that had at least one EMA after the baseline. We got predominantly girls with 80% and older age, so people reaching the limit of the adolescent age, not the younger ones. And some of the results about the impact of COVID, or the not the COVID itself, but the physical distance policies implemented since 23 of March in Australia, in New South Wales specifically. We had decrease in the fast food consumption. This is great, right? But this is not. This is mostly because the fast foods were closed, so they were not able to eat there. So, well, it's not a bad idea at all. And we had a decrease in physical activity, although we were not we were allowed here to leave the home for exercising, of course. Without the daily activities, the physical activity will be less likely to happen, and increase the time they spend alone. So they had this question, who were you in the last hour? And the chance of being alone is twice as before the COVID. And increase the time spent in social media and in internet use, the screen time were up, and some positive emotions, happiness, they were all going down. So, but it was not enough, or we were not able to capture a significant increase in the psychological distress. Probably because of the design of the questions itself. Here are some data got from the sensors and from the EMAs. Those are the percentage of participants that answer each that did physical activity, with a small decrease here in March, and the number of steps going really down, and the screen time, the time they spent with the screen on, went up very high. We can see that the happiness were going down since the end of the holidays. It's not just COVID, and the distress were going up. So as a pilot study, this was very interesting. However, we had a high attrition in the participants, and this is a problem with all longitudinal study, of course, but this is something that we really need to think about. We had a small gift pay of $30, which was not enough. So we need to think about strategies to increase the adherence, especially the gamification of participation. This is something that is really attractive usually. And we had the self-reported data in most of cases, which is interesting, but it is also interesting to cross the self-reported data with the sensor data. And we also had problems with the low number of participants with less than 16 years old, probably due to the additional consent process involving parents, guardian in the process. Well, we had a decrease in physical activity, decrease in fast food consumption, but no change in fruit and vegetables. So it means that it wasn't a change of diet itself. It's more it's getting harder to get access to the fast food, and increase in the loneliness and social media use. I think the study was quite interesting, but and highlighted some real problems that we need to face in the future to increase the participation. And also, I think it was interesting to use the smartphone to keep following up the participants, because it is something, as I said, it's something that is with you all the day, every day. Well, not for everyone, but for most of us, and it solves a lot of problems when we think about longitudinal studies, uh, because you can access people easier, and you don't need the real war, uh, uh, the real trouble to get all the longitudinal study in place to start a new wave every year or every couple of years. And that's it. Thank you all.
Thank you. Thank you, Sandro. That was really interesting. I'll just, in the interest of time, I'll just move on quickly to Simon. So we have Mr. Simon Chu, who's a PhD candidate with the Prevention Centre and based at University of Sydney. And Simon's going to be presenting on component C of this body of work, which is the development of a national decision support tool for child and adolescent overweight and obesity. And he'll be talking about some of the early insights from the model. So I'll hand over to you, Simon.
Thanks, Louise. Hopefully everyone can hear me, and hopefully I have control. So let's just try this. So a quick overview of what this component was. As Louise mentioned, the main aim of this component was to develop a national decision support tool. And the goal of that was to best inform buy-in for interventions of tackling child and adolescent overweight and obesity. Because it was a system dynamic model, we were able to also create an interface that would help users facilitate their own testing and looking at different strategies. And we're hoping to be able to publish that up on the cloud and give access to the stakeholders that were involved. And then I think the goal is to release it to a wider community as well. And as mentioned, the support tool was developed as a system dynamic model, and we went through a participatory development of the members that are here today to come along to workshops and help us understand a lot of the causal mechanisms that drive childhood obesity and how we can better develop the model. So Nate touched on a lot of the reasons why we do modeling, but a few unique features of system dynamic modeling compared to the hybrid or agent-based modeling that Nate was discussing was that we use stocks to represent populations, and they're just a big bucket of people, and flows allow us to understand how those populations change over time, and they really represent a lot of the rates of change that we expect to see in the population. And using those two fairly simplistic structures, we can lay them on top of each other to create a much more rich dynamic representation of population. Where this model specifically differs from the agent-based modeling method is that it's an aggregate level model. So we're looking primarily using at both primary and secondary data, but if we do use primary data, it's still aggregated up to a point estimate that's included in the model. And therefore, it's a top-down approach rather than an agent-based approach, which allows us to see the emergence of population dynamics. We're really looking at it from the national level and producing and using those aggregate level estimates to understand population dynamics. But that allows us to have quite a broad scope of determinants, so it's much easier to find data and use data to specify specific determinants that we believe to be important in childhood obesity. And it's the data requirements used to specify a system dynamic model is a bit lighter than you might find in agent-based models, so that works in our favor. Additionally, it's relatively fast to compute, so we can have that real-time testing in an interface and allow users to test their different scenarios and see the results sort of lay out in real time. So this is just a picture of which I think I've used in a lot of presentations now to sort of show how interesting it was to go through that process of having the workshops, how engaged everyone that came were in the project, and I really thank everyone that did come along. And you can see everyone, around the table trying to put down their post-it notes of where they believe different aspects and different relationships occur within the process. And this is that I find one of the more exciting parts of the project, because it really showed us what structures to rely on, what relationships to gather, and being a more quantitative person and seeing the researchers in action was quite interesting to see. It was my job then to take that big brown paper with all the post-it notes and try to understand a lot of the causal mechanisms or a lot of the structure that we wanted to include in the model, and then look at what data we could use to ground the model to operationalize the running of the model. So this was the first iteration when I was just trying to clean up a lot of the effects and try and detangle a lot of the things that were in there. And eventually it came to this structure, which doesn't represent everything that was included in the workshops, but it was more of a time and space and data, what we could use that limited what we could include in the final model. So it's much too small to see the individual detail, but the main structures of the model are this aging BMI chain where individuals or the population is initiated in these stocks, in these buckets of people that we have categorized as the different BMI categories. And then as the model runs, they age out of those buckets into the next age group we've considered, as well as based on an energy balance structure of the model, they can move up and down the BMI structure. As we intervene on the population, the amount of people that have been diverted from higher BMI categories or have been reduced from their current BMI categories are captured in this relapse structure, and then we can better understand how we might specify or how we might hypothesize relapse be occurring in the population. And an interesting aspect of this model was trying to incorporate an intergenerational effect where we were looking at how children start off in the model and whether changes in the BMI of the high fertility ages impacts how they start in the model. So we looked at 5 scenarios here. We were looking at how the early childhood prevention programs, such as breastfeeding and healthy choices and in infants and promoting active play, interact with overweight and obesity, as well as interventions in childcare services, interventions in school services, as how increasing sport and organized activity would change childhood overweight and obesity, and then again the sugar sweetened beverage tax, which was structured very similar to how Bryce and Nate had structured their sugar sweetened beverage tax. So I'll just describe this plot before we go into the results. On the y-axis, we have the change in prevalence of obesity, and I've mainly focused on looking at what the difference between the baseline model, the model that is run without an intervention, compares with the model run where an intervention is implemented. And the shaded areas in each of the lines are a sense of how uncertain we might be of those estimates. And we've gained that uncertainty by looking at what variables go into structuring an intervention and how and randomizing or sampling from those assumptions to better understand what range of outcomes we might expect to see in each scenario. And the solid line is just the average estimate over time. So this is what we might see in a lot of papers with system diet modeling. There's a publication on, they often publish this change over time, and this really shows how long it might be until we might see a full effect of an intervention. Each of the interventions were structured to have a 5-year rollout phase, but you can see that sometimes it can take 10 to 15 years before we see the full effect of an intervention coming through at a population level. And a lot of that has to do with how the age group of interest, whether it's children or adolescents, how that length of age that we're looking at interacts with the saturation of the intervention over time. As well as we can also see in the childcare intervention scenario where there's a delay in effect in adolescence as the children, they're a part of the intervention but then age into adolescence, and there's still some sort of a washout, but some effect there. Another way that I find quite interesting to analyze the data is to look at cohorts and how cohorts change over time. And this lets us sort of tell a rich story about someone's path going through childhood, adolescence, and into adulthood. And here we look at the four interventions specifically, ones that are focused on delivering programs to children, and then ones that are more focused on adolescents. So in terms of the early childhood prevention, as well as the childcare-based interventions, we see that there is a waning effect, and the peak of especially the childcare intervention occurs at the 6-year-old age group, and then as they start school and they're no longer at the childcare settings, then that intervention starts to wane. Conversely, as the children enter school and there's additional supporting programs to help them reduce overweight and obesity in schools, we see an uptick of an effect. Similarly, the sports vouchers, the participation profile around age is heavily skewed towards adolescence, so we see a much bigger effect in adolescence compared to early age groups. And the shaded region here again indicate the uncertainty around these estimates. The reason I plotted it like this is so that we can have a look at when we combine these interventions. So here, the purple line is combining all children-focused interventions, and the maroon line is looking at all adolescent-focused interventions. But this gold brown line actually looks at all interventions in total, and we can see that if we have if we support individuals over their life course, over the childhood and adolescent spectrum, then we get some additional payoff, and the washout doesn't occur till much later. And you can extend that thinking to think if we had an adulthood intervention, then we could start to bend that curve again. Sugar sweetened beverage was shown to be quite successful in component A, and it was one of the single most successful interventions that we saw in the intervention. But we do understand that there's a little bit of political stickiness with suggesting that to decision makers. So we also looked at how the combination of those other interventions compares against sugar sweetened beverage. And what we saw is that while sugar sweetened beverage was a very high exposure and high adherence intervention, we could start to replicate some of the benefits that we saw by supporting children and adolescents through the whole life course. And I think that's a quite interesting aspect, is that we can replace a high exposure with exposure over the whole life course and still get relatively good reduction in childhood obesity. However, that comes at a cost because we're running 4 interventions versus 1. Additionally, you could argue that taxation, you could spend that money elsewhere to support the healthcare services. So in conclusion, I think we're going to be fine for time. This component was a co-developed system dynamic model looking at Australian children and adolescents. And we're able to run scenarios in a like-for-like comparison because we all have each scenario has similar assumptions. And some of the characteristics that made interventions very successful were the idea around exposure and fidelity, as well as where interventions were set, so whether it was a school or a childcare centre. And those aspects, I think, are really key in understanding how we can further the reduction into adulthood. While sugar sweetened beverage was the best performing single interventions due to its high adherence, we think that having multiple interventions that support individuals over the life course can also replicate some pretty good findings in reducing childhood overweight and obesity. And that's, I think, my presentation done. So Louise, do you want to take us out?
Yeah, thanks, Simon. That was really interesting as well. So I'm just going to make a couple of points around the sort of local impacts from this work. So I was fortunate enough to be involved across all of these projects. I was seconded from ACT Health, so my usual workplace is with the epidemiology section in ACT Health, but I worked as an outposted officer, I guess, for the Prevention Centre for a number of years to coordinate all of these projects. And I really learned a lot. And from the local impact perspective, I guess I can speak from the ACT Health perspective, but I think that there's broader impacts of this work that other people would be able to speak more to. But where I'll start is just involvement in the diabetes in pregnancy modelling provided us with quite a few insights into the need for both targeted interventions as well as population level interventions to prevent diabetes in pregnancy. So what some of the earlier scenarios that weren't presented today showed us that those targeted interventions really didn't have an impact at the population level, even though they were really important for the individuals who were at risk. So one of those early insights is that we need to be working at both levels of scale. So we need to be working with people who are at risk plus doing the prevention work in the population. And one of the other insights that I think has come through very clearly from the presentations that we've seen today is the importance of preventing overweight and obesity in young people, in children and adolescents, and setting them up for a healthy trajectory as they enter adulthood, and the intergenerational impact that has across the life course. This modelling work also led ACT Health into being involved in the compelling case for prevention modelling work. And there were a number of agent-based models that were developed out of that project, which was also funded by the Prevention Centre. And so the modelling work that we were involved with was agent-based models for the prevention of tobacco uptake, so prevention of smoking amongst young people, but also prevention of alcohol-related harm, also targeting young people. And the insights from those models really informed some of the work on the ACT Preventive Health Plan Action Plan. But then, as with much of our work, we were sort of looking at the next phases and what we would move on to, and COVID hit us. And so that became quite a significant tangent. And so the focus of our modelling changed, and we became more focused on sort of COVID modelling work with Nate. In terms of the Ethica component B of this project, so the Ethica project that Sandro has described today really led us to understand how that platform could be used to supplement and complement our population health surveys at ACT Health. So we could see that this app-based data collection methodologies could be used to target some of the harder to reach groups. So, in the Western Sydney study, it was looking at adolescents and young adults, and that particular target group, as well as other groups, are actually quite hard for us to sample at reliable levels in our probabilistic population health sample surveys. And so we've been investigating doing a pilot, and that's something that we're hoping to roll out over the next 6 to 12 months, is a pilot of using the Ethica platform to target some of our subpopulations that we would like to understand better. For example, people living with disability or the LGBTIQ plus community in the ACT. So more broadly, I think that this work was one of the early projects that the Prevention Centre funded. And when we think about dynamic simulation modelling in Australia, I think that we really need to thank the Prevention Centre for taking that initiative and having the foresight to invest in a number of these projects, and the projects have led to the establishment of the decision analytics team, which has also meant that just many jurisdictions in Australia now have dynamic simulation models that they can use for policy decision making, and the Prevention Centre is really leading the way in Australia on this work. And I think that that's recognised by some of the international interest in the work of the Prevention Centre. Just in the last week or so, we had a consortium from the Danish group from the, let me just check my notes to get their name right, the Danish International Prevention Lab. And they came because they're really keen to learn more and follow in the footsteps of the Prevention Centre. And also, in practical terms, the impact of some of these projects. So Simon and I were recently invited to present the National Decision Support Model to the Federal Health Minister's advisors. And so, you know, we hope that some of these methods that we're developing will be used more for decision making. We had some of the members of the National Obesity Strategy Working Group were involved in the model development, and we're continuing to talk with them about how the model can contribute to that process. And also we're working quite closely with Professor Luke Wolfenden and his team at University of Newcastle and the National Centre for Implementation Science, and they're including system modelling to explore potential facilitators, barriers and impacts of scaling up school-based interventions like the Swap It program. So there's a lot going on, a lot has come from this program, but I'm going to finish there. I think there's a lot more that I could probably talk about, but we have maybe 4 minutes left for questions. So perhaps if people have big questions that they won't have a chance to ask today, all of our contact details are on this slide. And so feel free to send us an email. But if there's any questions that people would like to ask, please put them in the chat. I'm not sure, Karen, if you see any questions that have already been put in there.
No, I haven't noticed any, Louise.
Okay. So I guess I'll start with a question. I had a question. So somebody's asked if we could circulate publications. So a lot of all of the publications for these projects are actually on the project page, which Cindy has put the link into the chat. So yeah, so I think that's always kept up to date by Ainsley and the team. So they should all be there. So Sandra, I was interested to know whether there's any further plans for using Ethica, the Ethica platform.
Oh, we have many plans that we are looking for. The most recent one is to use this to follow people after self-harm presentations to ED. But we are still developing the questions itself. Actually, we will start with a qualitative study first to understand better which are the key questions, because we have many variables, but it's quite hard to predict suicide behaviors, of course. So we are trying to understand this better, and then keep following them with these apps, sending them help, of course, contacts of a message of help and reinforcements and etc. But also asking them questions to understand what changes right before self-harm behavior. And you can use this, for instance, with conjunction with the 45 and up, for instance. This is something we were thinking about some time ago. I believe SACS is already working on that. So we can follow people in a looking closer than with paper questionnaires that we send by mail.
Yeah, excellent. That's really interesting. So there actually are no questions in the chat at the moment. We have 1 minute left of time, but perhaps I'll close. So Tim's also said that there's people's contact details. So we're all happy to be contacted for questions following the webinar. And I know that Louise Bauer and Joanne Occhipinti will be really disappointed that they missed participating in the webinar today, and I'm disappointed that we didn't get to hear their reflections. I think that would have been really valuable, but yeah, it is just how the day has turned out. Okay, so I've got a question here from Maddie. Are there plans to model other population interventions like digital marketing to kids to compare against the other interventions? So I don't know if Simon or Nate want to tackle that one.
Yeah, I'm always keen for more interventions and more scenarios. If we have, good population estimates of how we believe those differences occur, then we can start to look at how they roll out at a population level in the modeled scenarios. Yeah, and part of the goal of having the interface there is to have enough flexibility to structure, particular scenarios that people are interested in. While that scenario might need some particular tweaking, then there is functionality to test out, user-driven scenarios.
And Nate, yeah.
Yeah, I'll just make two remarks with respect to that. Together with some overlap with some of the folks involved here, such as Joanne Occhipinti, we're quite involved with use of agent-based modeling, looking at social media exposure as it relates to unhealthy and often mental health challenges and even suicidal behavior by adolescents, and particularly looking at the chat safe interventions. And I think modeling can be a very effective tool, and looking at a finer grained level at the particular designs of restrictions and efforts to mediate that impact on children and youth, to understand its subsequent health effects. I would further note, and this is a broader point, but it particularly fits like a glove here, that some of the types of data collected by Sandro's types of studies could be married with these finer grained dynamic models to really richly inform an understanding of those exposures at baseline, and to link them up to representations of behavior change and health harms. So there's a real opportunity here to bring together that sort of rich data-driven portrait emerging from Sandro's work with collaborators with this dynamic modeling to better understand exactly how much leverage you might get with various types of restrictions or limits to exposure there. Yeah.
Thank you. Lucy, did you want to say anything to close off the webinar? Sorry to put you on the spot. No, she might be struggling with her mute button, but I'd just like to say thank you very much to all of our presenters today. I mean, it has been such a fantastic project to work on with all of you, and I think we've produced some really fantastic insights and made a really valuable contribution. So thank you Nate and Sandro and Simon and all of the teams that were involved in all of those components. And yes, we're looking forward to doing more in the future.
See you.
Thanks. It's a great honor.
And
Take
thanks
care.
for everyone who attended today.